Hello gophers and welcome back to new series on packages in Go. In this video, we'll be learning about the print functions available in the FMT package. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications of any new videos that we put forward. So let's start by understanding the different type of print functions available in FMT package. So we basically have 9 types of print functions that are available in a FMT package, namely the print, printf, println, fprint, fprintf, fprintln, sprint, sprintf, and sprintln. Now all these 9 types are basically grouped into only 3 types. If you understand the 3 basic type of print functions, the other remains almost the same, just they are different in where they would be writing those output to. So the print functions would write output to your console. The fprint functions would expect a writer as an input where io.writer has to be supplied and you need to tell the function where it needs to write. The sprintf is a function where it will return a string, the formatted string. Now you can do whatever you want to do with the string, whether you want to write it into a text file or on a console, that's completely upon you. So we'll only discuss about the basic 3 print functions that are available, and then we'll start using the other functions as well. So the basic print function that is available in the print FMT package is a function where you need to supply n number of arguments of any type, and it will concat all those into one and print that. The resulting output of this function is generally having 2 variables or 2 output, where the first one is the integer variable which says that the number of bytes being printed. Second is error, in case there was some error being encountered when we had printed this statement. So by default, in print function, it will not append or not separate the different variables with a space by default. But if the input variables, all the input variables are non-string type, then it will append a space in between all those. So if you pass strings of on at least one string, then it will stop adding a space by default. So now let's start by printing this function, and let's see how it behaves. So it has printed a FMT print function that was given. Now backslash n is a special character that helps me in breaking the line, which is certainly not visible right now. Now let's also print one more function where I have accessed the argument that was returned from the print function, and let's see how many characters have it printed or bytes have it printed. So it says it printed 8 bytes, wherein high and there is only of 7. But we also had a backslash n that counts to 1 byte again. Now let's print a non-string variables, and let's see if we get a space. Yes, we do get a space. Now I had one more example where we'll see how this behaves if this was a string. So one was string and one was a number. Now if you see, we don't get a space by default. So 10 and 12 are not separated by spaces. But if I remove this quotes and convert it into integer, now if I see, it's adding a space. So this is how you can use a print function. Now let's start by understanding how we can use a print ln function. Now print ln will add a backslash n automatically, so you don't have to edit uh, mandatorily by yourself. So there is 1 byte that is always added by the print ln automatically. So now let's run this program and see the different outputs. So if I see high and there are separated by a space which was not done by the print function. So print ln does that, and it has already added a backslash n. Now if you know high and there are only 7 bytes, one is the space between these two and one is backslash n, that counts to 9 bytes of data being printed on the console. and if you have a non-string arguments as well, so it behaves as it was behaving with the print function. So let's now go ahead and let's start discussing the printf function, where we can specially format the output string to the format that we desire or we want to. So now let's say I have two variables, one is of type integer and other is of type string, and I want to print these into one line and say that the cost of the product by this name is this cost. So hi there, the cost of the product name should come over here and the cost in rupees should be displayed over here. Now we have a list of special characters, or let's say these are some sort of arguments that you need to supply in the printf function that will help you in formatting the string. And this function printf expects two major arguments. So the first one is a string, definitely that needs to be formatted, and second one is the list of arguments that will be used to replace these special characters that are percentage s, percentage d, and we have a list of these uh, that is there on the Go website, and they have mentioned like percentage V, percentage hash V, percentage capital T, and we'll look into some of these, and then we can go ahead and start using the others that suits to your requirements. So over here we'll be discussing majorly on the basic ones that are very commonly used, and then the specifics ones you can go ahead and read it from the Go package website. So let's say I have now taken the A3 as the output from the printf function. Again, this A3 is number of bytes that are being printed. But now that we are already aware how these bytes have been counted, I'll remove this and let's start printing it. For the next, I'll also remove this line. So, so you can see hi there, the cost of percentage s was replaced by the first argument. Now you need to be very careful in supplying the list of argument, because the first characters would be replaced with the first object from the list of variables that you supply over here. Now, if you supply this in a random fashion, then there will be a compile time error where, runtime error, where it says that it will not be able to replace these values. Now, if you see the cost of, now if you see this is mentioning you that you wanted this to be a type string, but this 1000 was actually of type int, and the 1000 was in the cost, and wherein this was expecting a integer variable. Now d percentage d specifically stands for an integer, so it says that it expected a percentage d, but you have supplied a string. So you need to be very careful in passing the arguments in the same order in which you have used the special symbols. Now let's say I have an structure. So I have declared a structure which contains two arguments or two variables, cost and name, of type integer and string respectively. Now I am creating a variable for the product, assigning the values to the product. Now let's print this with percentage %v. Now percentage %v is again helping you to print the values in the default format. Now default format that is used by percentage %v is being displayed and being given to you in the Go website, where it says that for a bool it will use percentage %t by default, for integer percentage %t, unsigned integer percentage %t again, and the then for float it will use percentage %g, for string percentage %s, and character percentage %p. So now let's go ahead and start printing this. Now this printf will not add a line break, so you need to give it by your own so that it breaks the line. So if you see over here, I have got printed as product one hyphen and the value. So the value would be printed as the variables in the struct, and it will be printed in the same order that in which it was actually declared. So the first one would be the first variable that was being declared over here. So it got printed. Now at times you might feel that I want the name of the variable as well. So that can be done by adding a special character, that is a plus symbol before p, that give you a complete insight of the variable name as well. So this is how you can print a struct as well. Now let's see if we can print a percentage sign. To print a percentage sign, we need to give a double percentage symbol so that it knows that we need to escape this and escape this and print percentage. So percentage sign is printed. Now let's see if we can print a variable. So boolean will always be printed as true and false. So flag as true. So this is how. Now a very special variable type, that is a float. Now let's start discussing about formats that are available for float. Now I have a price variable that is of type float definitely, and now let's start printing it. So for a float we have to use a percentage f, and if I see, I've got the integer part as such, and the decimal part contains default zeros that are added to this. So this comes with the type of float that was declared. So by default it is like float 32 or float 64. According to it, it will add some zeros to it. Now if you want particular precision, let's say I want to have only three decimal places, I mentioned as dot 3 then f. That means that I just want three decimal precision, three decimal place precision. Now let's say if this was something like this of four decimal places, and let's see if it does round or not. So if you see, it gets rounded off because you said we want of three decimal precision. That means it will round this off, and let's see if how this behaves. So if you see, it's 5 7, and if it was 4, then it would be 5 6 only. So this is how you can actually format your float type variable, where you can mention that how many particular uh, precision points that you want from a float variable. So these are the basic formatters that you will be using on your day-to-day life, and there are n number of formatters that are available. So I'll put the link of this FMT package in the description of the video so that you can go ahead and have a look at it and play around with it. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.